All right, Project Genesis for Astronomy 101. 24 Buddhist B. The discovery of the planet 24 Buddhist B was confirmed in 2018 by NASA. It is a gas giant exoplanet that is ringless and orbits a K-type star, which is a main sequence star. A gas giant exoplanet is a planet that is composed mostly of gases such as helium and or hydrogen and have small rocky cores. The 24 Buddhist B is located approximately 313 light years from Earth, which is about 7,500,000,000 times as the distance from the Earth to the Moon. It is in the Buddhist constellation, which contains a total of 25 exoplanets. 24 Buddhist B is a large planet, 1.24 times the size of Jupiter. To put things into perspective, Jupiter itself is large enough that it would take 1,300 Earths to fill its volume. So the Earth, in comparison to 24 Bu B, as it's commonly referred to, is microscopic, a speck compared to this gas giant. The planet orbits a planet star 24 Buddhist. The planet exerts a small tug on the star, shifting its position just enough so that it's detected from Earth. It takes 30.4 days to complete one orbit around its star and is 0.19 AU from its star. An AU, or astronomical unit, is approximately 93 million miles, or the distance from the Earth to our Sun. The AU indicates that the star, 24 Buddhist, is almost directly in contact with the planet. The planet has an orbital period of 30.4 around its star. It is one of the shortest orbital periods among those found around the evolved star using radial velocity methods. The planet is also gravitationally locked within its star. The planet orbits the star 24 Buddhist and has such a close proximity to it that a moon is unable to form. Moons are necessary to help stabilize the climate. Gas giants are often composed of a dense, hard, rocky core, a liquid mantle that contains metallic hydrogen and helium, and an atmosphere that is made of molecular hydrogen and helium. Since these planets are composed of gases, they do not have solid surface, but one that is composed of various gases. The planet Bu B has a surface gravity of 2.79, which, when compared to Earth's surface gravity of 9.789, illustrates just how little gravity there is on the planet. An interesting fact when comparing the gas giant Bu B to Jupiter is that Jupiter, while a gas planet just like Bu B, has a surface gravity of 24.92, which is very, very high. Since 24 Bu B is a gas giant, just like Jupiter, we can analyze what we know to be factual when it comes to the general climate and atmosphere. The planet is a stormy whirlpool of wind, dense gases composed of hydrogen, helium, methane, and ammonia. Since it is composed of gases, there is no actual surface, just swirling clouds composed most likely of ammonia ice crystals that melt into droplets the closer they get to the surface. The temperature would be extreme, with negative 280 degrees Fahrenheit at the tops of the clouds and negative 238 degrees Fahrenheit on the surface. So very, very, very cold. One considerable difference, however, between Jupiter and Booby is the amount of gravity, with Jupiter's rocky core lying deep below the surface with the temperature around 36,000 degrees Fahrenheit. These extremely hot temperatures are a result of Jupiter's gravitational compression, something Booby does not have to worry about considering its near absent gravity. So, what would it look like if we had life on a planet composed of only gases and extreme temperatures? Well, believe it or not, there have been theories about what kind of life form would be able to inhabit such a planet, and they are called Jovians. Many famous science fiction writers, astrobiologists, and even the famous Carl Sagan had theorized what types of life would exist on gas planets, specifically one as Jupiter, since we know so much about its composition. They are seen as large, almost jellyfish-like type creatures with gray skin and hollow bodies that they use to fill with air and propel themselves around. To control its speed, the Jovian simply must contract its body. The contraction also serves a secondary purpose, but that will be explained later. They are non-sapient creatures, meaning they lack the capacity for higher cognitive functioning. Jovians have thick gray skin with large pores on their upper bodies, helping to absorb nutrients from the environment. Their complex circulatory system helps deliver those nutrients to its cells. The Jovian can excrete their waste each time they contract their bodies to move throughout the atmosphere. They are anywhere from 2 feet to 5 feet in size and are asexual, both in orientation and reproduction. Each Jovian has an approximate lifespan of 30 days, or one rotation around the star 24 Buddhist. Once a Jovian has reached the end of its lifespan, its body will slowly begin to be consumed back into the atmosphere, reverting into molecular hydrogen and helium. Upon its death, a small bit of sulfur is purged into the air, instantly forming a new Jovian. A Jovian's food source are chemotrophs, small organisms like bacteria or fungi that can use inorganic compounds such as hydrogen, sulfur to survive. Chemotrophs may include methanogens, halophiles, nitrophiles, thermophiles, and sulfur oxidizers, just to name a few. Chemotrophs obtain energy through chemosynthesis rather than photosynthesis. Each Jovian can intake as many chemotrophs as they can hold within a 30-day lifespan, excreting all the waste from their bodies as they travel through the windy surface. Here are the references for the project, and this concludes my presentation.